The last thing I want to talk about before we wrap up adding and subtracting rationals is the idea of a compound fraction. And what a compound fraction is basically just the ugliest thing you've ever seen, right? It's a fraction with fractions inside it. And the fractions inside it are in like addition subtraction problems. And then there's a division going on, and it's just terrible. But you have to know how to deal with these things because, well, for one thing, every now and then on your ACT coming up, there's going to be a compound fraction. And for another, when we get into our trigonometry unit, knowing how to deal with these compound fractions will be very useful for you in several of the sections. So what I'm going to do is, instead of, you might think, well, let's just add up these fractions, turn them into one fraction, and then let's add up these fractions down here, turn those into one fraction, and then do a division. And there's nothing really wrong with that. You can absolutely go ahead and do that. And you will get the right answer as long as you don't make any mistakes. But I want to introduce a different technique that we're going to do here. And let me just crop the side of this in a little bit. What I'm going to do is I'm going to multiply the top and bottom of this fraction by terms in order to clear the denominators. That's the technique I'm going to use here. And the reason I'm picking this is because this is just a generally good math skill for you guys to have. And it's not a bad way to do the problem too. So I'm going to multiply by a crazy one. And the crazy one that I'm picking is going to fix all of the problems that I have in here. And what are my problems? The problems are denominators within a fraction. It's just awful. So I'm going to multiply the top by 5 plus 3 and 5 minus 6. It's going to get a little ugly, but that multiplied in here is going to get rid of all those denominators. And the next on the bottom, of course, is going to multiply by the same thing. Now, if you have some compound fraction sometime with more than two factors in it, or more than two types of denominators, see, I only have two, 5 plus 3 and 5 minus 6. But if you had a compound fraction with 3 or 4 or more denominators in it, you would just keep getting a longer and a longer crazy one. But I think the point will be well illustrated here. So what you're going to do is you're going to take this whole, let me pick a color that shows up well here. You're going to take this whole numerator and you're going to multiply it against that fraction and also against this fraction right here. So let's go ahead and do that. 5 plus 3, 5 minus 6 times the fraction on the left gives you just, well, I'll do this one in detail, and then I'll speed it up once we see how it's working. 5 minus 6 over 5 plus 3. See, that's just this fraction on the left here, brought down here. And you can see what's going to cross out, right? That 5 plus 3, which is kind of the point. We were trying to cross that out. And what you would get is just 5 times 5 minus 6. Okay, so I'm going to go a little more quickly now. The top right fraction cancels out its 5 minus 6, and all you have left is 4 times 5 plus 3. And then we have a big denominator. And on the bottom, you have negative 5 times 5 minus 6 and negative 3 times 5 plus 3. Okay, now it's just a job of collecting some like terms together. So on the top, let's go through this and split up those parentheses. I have 5 phi minus 30 and minus 4 phi minus 12. The denominator is negative 5 phi plus 30 minus 3 phi minus 9. And we're collecting our terms again together. So 5 minus 4 on the top is just a single phi. Negative 30 minus 12 is minus 42. And on the bottom we have negative 8 phi. And 30 minus 9 is 21. Okay, so that is your answer. There's no GCFs. There's nothing else you can pull out of that to simplify it. We're all done.